Okay, hi, this is a video on differential equations with logarithms. So we're just going to do example 4 in here. So please turn to the very last page of the PowerPoint. Alrighty, so it looks like this. So the steps are the same as any differential equations, but with when ln is involved, I recommend a slightly different order. And the other thing I recommend is to solve for e to the c instead of just c. So let's review the steps. Separate the variables, integrate both sides, solve for y. So I suggest doing that at step 3 as opposed to at the end. Then you'll sub in and solve for e to the c, and then you put your e to the c back in and you'll be done because you've already solved for y. All right, so let's see what this looks like. So this is my problem, right? So go ahead, separate the variables. Now when you separate the variables, here's a tip. Leave the 3 where it is. Do not divide by 3 on both sides because then you'll be creating a fraction, which is unnecessary. So just leave the 3 where it is when you separate your variables. Okay, go ahead. Okay, so this is what it looks like to separate the variables. Now you're going to integrate both sides. You're going to integrate both sides. Now this integral here, this 3, I mean, you could write it on the outside like you can any constant. So if it helps to rewrite it this way, you may, if you want to do a rewrite step, but this time the rewrite step is not totally obligatory. And then I'm going to integrate. So go ahead and integrate both sides, please. Okay, this is the integral of both sides. There we go. So now I've separated the variables. It's 1. Integrated both sides. It's 2. My next step is to solve for y. So to start getting y alone, I'm going to need to get rid of the ln. So I rewrite it as an exponential with base e to get rid of this ln to start getting y alone. So e to the all of this equals absolute value of y. Okay. Now before I go on, I'm going to take this 3 and rewrite it, reposition it within here using a logarithm rule, like a pre-calc log rule. So that looks like this. Okay. So this would be, if I'm doing RIS, this would be, all of this would be the simplify stage. Okay, so now I know that I'm going to rewrite the top, so the right side, so that there's not addition in the exponents. So how do you rewrite that right side? There's a couple steps, but yeah. Okay, this is the first way to rewrite it. So addition in the exponent is the same as multiplication with like bases. So see my like bases there? Now, to keep going, the e and the ln cancel, okay? So I have absolute value of y equals just this, the e and the ln are gone, times e to the c. So let's see what that looks like. Okay, now I haven't finished solving for y yet because y is not alone, it has these absolute values. So I'm going to take away the absolute values to fully solve for y. So I know that's a plus or minus if I take away the absolute values, and I'm going to look at the y value, and it's actually a positive. So between the plus or minus that would go on the right, I'm going to choose the positive case. So that's it, now solved for y. Great. Okay, so now that's step 3. Step 4, okay, step 4 is to plug in each of these x and y values and solve for e to the c, not c, but e to the c. Okay, so let's go ahead and do that. There we go. So e to the c is a half. Okay, and then I put that e to the c back in. So go ahead, put the e to the c back in. So I'll put it into this guy. And so it'd be at the times it by the end. I like to put my coefficients at the beginning. So that is my answer. So you might have written first y equals absolute value of x cubed times a half. And this absolute value you can't take away. And you don't have to because y is alone, and that's how your final answer should look, so you're good. But all right, there we go. So thank you very much. Hope you're doing well. And that is the last of our notes for this whole unit on logarithms and exponentials. Bye.